So hello everyone, I'm Andrew Korte.
I'm Matthew Bellafaire.
And the Shamoon.
Hadeel, Polus.
And so for our project, we did a video canvas. So it's just like a kind of a fun painting program that uses hand detection to help you like paint across the screen, and also to kind of paint pictures. So we'll go ahead and we'll just get started with the demo.
Hello, this is Group 6 video canvas.
Oh, can you hear it now?
Start with a paint picture, so press 1.
Yes.
Okay.
So a color palette will pop up. And we go ahead and just right click on the color that we want to use. After we right click, we press G. And as you can see, it'll pull up to a couple of different images. So on the right, you can see my finger. This is the actual video feed. And then on the left is the picture that we actually want to paint. So what we're going to do is we're going to put our finger up and we're just going to shake it a little bit to keep it in the same spot. And as you can see, everywhere in the picture that was connected to the outside gets colored in with the color that we selected. So what we can do is we can actually select another color. So if we click on the C key, the color palette will pop up. And we can actually just right click on a new color, press the G key to close the color palette. Let's see if we can get this to paint in a different section. Let's see if we switch hands. Sometimes it gets a bit busy, but as you can see, it just paints it in a different section with a different color. It only paints in the sections that are connected. So then after that, I guess if we want to go ahead and switch to the other painting mode, we just press Q and it will stop the program. So you actually have to stop and restart to get to the next painting mode. So you click on it, and then again we're prompted what picture mode we want to paint in. So this time we'll do the face paint. So we press 0, and then we'll press enter. And then we're actually prompted on what type of paintbrush that we want to use. So we can use a spray paint kind of paintbrush or just a normal solid fill-in paintbrush. So we'll start with the solid fill-in. So we'll press 0 and press enter. And our palette will be pulled up again. So we can go ahead and just right click on one. We'll select the yellow so it's nice and bright. And as you can see, it just goes ahead and tracks my finger based on where it's at and fills in those pixels with the color that we selected. You can see kind of on the right again, it just has a little pointer. It follows you around, kind of showing you where you're at. So then what we can do is we can actually press G and it will pause the video and allow us to select a different paintbrush. So we pull up our program file again, and as you can see down at the bottom, we're actually re-prompted on what paintbrush we'd like. So this time we're going to select the spray paint. So we'll press 1, and then we'll press enter. And then we will pull up our output, actually what we want to look at, along with, we can pull the other frame up. And as you can see, it starts to actually paint in spotty, so it looks more like spray paint and kind of randomize it. So if we want to, we can also change what color we're using in the middle of painting. So we just press the C key and we're re-prompted for our color palette. So we go ahead, we right click on a different color. So we'll do this green color, and then we'll press G to close it. And as you can see in the video, the green or the paintbrush will now actually paint green. And it will paint over everything that was already previously an image, including all the color. Another feature that is added to this is that we can actually we can erase with this. So the erasing is done best with the solid paintbrush. However, you can do it with the spray paint. So we'll first change to the solid paintbrush. We'll press B. Video will pause. We reopen our program window. we select the regular paintbrush and press enter. So then we'll go ahead and we will pull up our color output. And you can see, oh, we got actually, now we're back to our solid painting. So to actually select the erase, you press C to open up the color palette. And the way the program is set up, black will actually erase. So we right click on black, we press G to close, and then if we follow the finger, you can watch, it actually starts to erase some of the different, erase where the pixels were, showing what was actually in the original video frame. So there you go. And that is our project. So we're going to go ahead and press Q. The program should close. There we go. And that is the program.
All right, so we will go ahead. I'll do a live demo. Let me stop my video. All right, so kind of as you saw, we hit play on the program. Let's see, there we go. So then we're prompted what type of painting do we want to do. So we'll go again and we'll start with the paint a picture. So we type in 1, we press enter. And then here is our color palette. So this time we'll select maybe a blue, and then we'll be able to actually close it. So we press G. And as you can see, all of the different images start to pop up. So for the live demo, we actually selected a different picture. So as you can see, it tracks my finger, and then if I can get it to stay, see if we can't paint one of these. There we go. So then as you can see, it painted just the connected white areas. So if we want, like same as the demo, we can hold C and we'll get the color palette back. So we'll select red this time, then we'll close it. And let's see if we can't get this one right here. So we shake our finger, and as you can see, if you can just get the pointer to stay in one position for a couple of seconds, it'll actually paint any connected region where your finger is at. So we'll go ahead and we'll switch over to the face painting portion. So we close it, we press start again, and then we do face paint. And then we'll start with the spray paint for this one. So we're prompted, we're given the color palette. So we'll go ahead and we'll select purple and say G to close it. And as you can see, it starts tracking my finger and coloring in the different pixels where my finger is at. So then we can press B. You'll see the video feed pause. Then we can pull up our program window, and we're asked to select a different paintbrush. So we'll go and do the solid paintbrush, and then actually things will start moving again. So we go color output. And as you can see, it actually starts doing a solid fill. And then again, just to reiterate, if you want to erase, you go ahead and select black, close the color palette, and then you can slowly just start going through and erasing some of the different pixels. And then same with just selecting different colors. So that is it for the live demo. So we'll go ahead and we'll just move right into the presentation.
Okay, Video Canvas is a fun painting program that allows the user to do a face painting or to paint a picture. The project uses OpenCV in Python to do video and image processing. The project also uses the ideas of connected objects in the paint a picture portion of the program. Also, while in the face painting, bitewise and matrix operations are used in the face painting to do work on a video feed. Even though this project is used for fun, it can be expanded upon for industrial uses. For one example, would be integrating it with augmented reality and updating it to draw shapes. This would allow the program to do 3D modeling. The program could also be used in the fashion industry. Also, fashion designers could use their hands to make creative designs by drawing out their ideas. This would also be very useful in the animation field to draw up different scents. Now I'll move it to Matthew.
Thank you. Next slide. So the finger detection was a big component of this, and this is mostly what I worked on the project. So we're actually using a rule-based algorithm that we created, and it's based mostly on a OpenCV background subtractor. In this case, we're using the MOG2 algorithm, which is a mixture of Gaussian background subtractor. So it basically takes the background over multiple frames, figures out what's not moving and what is moving, and then gives you a mask off of the changes in the image. So in our case, we're actually tracking the finger, and because the finger is moving, it almost always comes through in the mask. So we use the background subtractor on our video feed after downsizing the image, and we end up with a mask that looks like this. And then we do a little bit of dilation and erosion just to remove some of the noise. We can't get it all, but we'll deal with it in the next slide. So once we have the contour, or once we have the mask, we're then able to find the contours. And what we do in order to extract the fingertip is kind of reliant on the shape of the fingertip. So we find the contour with OpenCV find contours function, and then we find all of the convex points that exist in the contour. So the advantage to doing this on a finger is that the fingertip generally has the most convex points that will appear. And so with that, we're actually able to go through all of the points detected, eliminate any stray outliers that were just found by the algorithm, and then find the tightest grouping of convex points. And then that's our fingertip. And we take that and we superimpose it over the last image, or over the input image. Now, this is a little bit noisy. It does sometimes detect things like the knuckle near the thumb and, near your pinky, but for the most part, it gets the fingertip correctly if the finger is moving quickly and is on a contrasting background. One advantage to doing it this way is that because we're using a background subtractor, we're mostly lighting independent. So this worked in my house, and it worked in Andrew's house. The only thing that can throw it through a loop is if there's just not enough contrast between your hand and the background. So sometimes moving over the face or moving over a bright region in the background will cause it to mess up. But because this algorithm is noisy, if we go to the next slide, we have to do some kind of filtering to the ultimate output because we have a point that's being tracked on the finger all the way across the screen, but that point may be jumping around. So what we do is we essentially make it so that the point is biased towards the next detection. So if I move my finger by 4 pixels, we move the point only 1 pixel in the direction of the new detection. So essentially the detection point will always be trailing the finger. And this way, instantaneous movements of the detection point do not affect the where the drawing happens very much. So consistent detections will move the point accurately, but very quick false detections do not result in the point being jumping around the screen. And I will now pass it off to Andrew.
All right, so when we went to go and actually overlay the color onto the video feed, we had a couple of issues that we had to kind of overcome. So because the video frame is taken in as an image, and because that image is updated many times a second, just doing processing on one of those frames won't keep the next frame updated. So we were kind of wondering, how do we go about updating every frame? So the original idea was to actually loop through every pixel of every frame and add the color as it was needed. But when we did that, it was extremely slow. So we originally started with like a 600 by 600 video frame, and even that was just extremely slow. So we switched over to using bitwise operations and matrix addition. So as you can see from the demo, it was much, much quicker. So just kind of some of these steps that go into overlaying onto the video frame. So first, a mask is created out of the canvas. So the canvas is up in the upper right-hand corner here. So it's a pure black 1920 by 1080 image that it keeps a running tab of what color is at what pixel. So we create a mask that will actually make the anywhere that's black in the canvas black and anywhere that's colored white. So then we invert that mask into the down here where the background becomes white and color becomes black. And then we bitwise and that to our video frame, which is down in the bottom left. So as you can see, each of the different spots where there's supposed to be color actually becomes black. And then afterwards, matrix addition is done. So what happens is because black has a value of 0, anywhere in the canvas that's black, it won't affect the color of the video frame. So we'll still keep that color. However, the opposite is also true. Anywhere that's black in the video frame will get whatever color is in the canvas, which kind of allows us to superimpose the color onto the particular video frame. And then just for the different brush types that were used. So we used 2 different brush types, one that was just a solid color, and then the other was kind of like the spray paint as you saw. So both are just a 20 by 20 matrix where every element in the solid paintbrush is considered a 1. And then in the spray paint, each element is randomized with a certain number, and then a threshold is placed on it. So numbers above a certain value were set to 0, while numbers below that value were set to 1. And then when we go to actually color on the canvas, it loops through the 20 by 20 array and just checks, is the element 1? And if so, make that color, make that particular pixel colored. So with that, I will pass it off to Hadeel.
Hi. This part will detect a hand to help with painting an area of an image. So we choose the image that we want to paint, and after running the program, we will press 1 for painting an image. After that, we will have to detect our finger on the spot that we want to paint, like for 1 to 2 seconds, and then that spot will be painted as shown. Like, and also we can paint for more than one color in image. Like, for example, the coin image, we can paint, like if we want to, we can paint every coin with different color. Next slide, please. So here a brief explanation about how the objects were connected. So we read in the image, and then we want to make it to black and white so that the connected connection will make the connected component connection to be running, and then after that we can paint an image. So now I'll pass it out to Andy.
Hi again. As a conclusion, using OpenCV tools, we can make several complex programs. This project contains of 2 painting modes. First one is picture painting, and second one is face painting. Video canvas can be expanded for many interesting industrial uses, like the user can integrate augmented reality to create 3D modeling by updating the program, to draw precise shapes and using hand motions to rotate the 3D modules. Also, it can be used in the fashion industry and animation. Next slide, please. Here's our reference. Thank you guys for listening, and any question?
Great job, group number 6.
Thank you.
Good demo and good presentation. I have to say, you seem to have a lot of fun doing this project. It looks like fun. I want to paint it with my finger also. Okay, let's open it up for questions here. Anybody? Okay, well, I will ask one. when you were showing the demo, I just want to make sure what we were seeing, the two videos next to each other. One was the painting or the template which you are trying to paint, and the other one was tracking your finger, the video actually. But what you were seeing when you were painting, were you seeing the dot on the painting itself, so you know where the paint is going to go? I couldn't tell from the video because it may be that what you were recording is not what you're actually seeing on the screen there. So you want to tell me about that a little bit?
Sure. So how it's set up currently, the output. So if you're doing the paint a picture, where you're actually just coloring in the picture, it doesn't show the where your finger is on the picture. That is something that we probably could improve on in the future. So you do have to have that second actual video feed so you can see yourself and where your finger is going.
Sure. So yeah, so I wasn't sure if you were seeing it, so you were approximating where the color is going. You can very easily, you know, superpose the finger position on the other image also. I think this is a minor thing. But you guys did very good. You know, you were able to do it and paint it and use connected components idea here to fill up the whole area with a color. So excellent job. More questions, please.
I have a question. So I'm actually watching here with my daughter. She wants to know how she can put this on her phone. She likes it so much. But along those lines, do you any limitations on the type of cameras that you guys use? Did it matter what type of camera that was used?
For the most part, no, because we're using a constant background subtractor. It generally works with any video frame. In fact, with the code that we have, we downsize the image to like 15% of its original resolution, so we could even run this on a very small camera without too much issue if processing power is limited.
Thank you.
Yes, there's a product in future here. Maybe on phone cameras, even front-facing phone cameras and all.
Exactly.
The screen, iPad, and all that. More questions? Okay. Well, I have to say this idea, the way you detected the finger is excellent. You're using motion here to do a difference of Gaussian, and that's an excellent way to detect it. Was this is this your original idea for the group, or was this something you found in the field also?
So we worked originally with Har Cascades, but we couldn't find one that could do a pointer finger. There was fist and hand, and neither of those were very good for what we're doing, particularly when we were moving fast. But for the most part, this algorithm was just kind of come up with. I did read a reference or a article about doing hand detection that used the background subtractor, but they did all kinds of other things like fitting lines over all the fingers and then using that to detect gestures, and we just didn't need that, so we developed something that was completely different from that.
No, the results are excellent, and the way you detected the finger in the motion, fastest moving probably, pixels in the stuff, and the proof is in the pudding that it worked. You were doing very reliably the finger painting there. So excellent.
I have a question. Can you use an object like a pen or something else other than your finger to paint or to for motion?
We didn't try, but it might work because the way the hand detection works, if it detects the most convex point. So you probably could, if you just made like a fist and then held like a pencil or a pen or something, it might be able to detect that and recognize that as the finger, maybe.
Okay, just curious.
Actually, Sam, that's a good idea to improve the contrast in the image. You can hold up a pen or a stick, which is, has a good contrast with the background.
Mhm.
So a lot of potential, yeah. Did you have any problems if there were motion in the video itself while you were detecting fingers? Did you try that?
Yeah, actually, if you move around a lot, like you move your body around a lot, it does result in some false positives very often. And that's just because when we do the hand processing, we take the largest contour because we're just assuming that the hand is the thing moving. But yeah, that is something we would need to improve.
Maybe it's a good idea for kids to paint with their fingers. They have to sit still while doing it. So I see many advantages here also. More questions? Did you think about using some predictive capabilities? Because if you're tracking your finger every frame to frame, the finger cannot jump very quickly in the next video frame. So maybe there is a certain area where you look for the finger. So that might even make your algorithm more robust, that you're not finding any other motion in the, once you track the finger, you are locked in, because you're going to find that finger in general neighborhood going from frame to frame in each video. And if there's any motion sidewise, it will just reject it. Did you think about certain ways to do it? If you had time, unlimited time here, what would you do?
Yeah, that's a great idea. We did have something like that in, like as it is right now, it's designed just to filter out very rapid movements, like one frame type of jumps. But cutting it off into like a smaller area would have probably improved things quite a bit. The only thing that we have like that is when the finger first is detected, it will jump to it, but it doesn't, afterwards, it doesn't, just tracks the last position.
Very good, very good. Okay, any last questions for this group? You have one more group to go. If not, great job, guys. Excellent demo.